Okay, well, welcome to classwork 8.4, angles of elevation and depression. Happy Tuesday, April 7th, which is when I'm filming this. Hope you're doing well. I just picked out two problems, one that I think is probably the trickiest on the classwork, and another one that's just a basic sample problem. Number 9, I think it might be one of the more complicated ones. 15 is pretty basic, but want to just do another review with you. So we'll just do them in order, even though I think you'll see 15 is much simpler. But number 9 is not that bad once we realize basically one simple trick and how to do it. Number 9 is about they're looking down they're surveying from the top of this cliff, and there's a river down at the bottom, and at the angle of depression, you can see there's their angles of depression from far side of the river is 58 degrees. The angle of depression down to the short side of the river is 74 degrees. And so they're asking you to calculate how far. This is what we want to know. We want to know how far across is the river. And as you can see, we don't have a formula to solve for this little triangle here, but what you mainly want to think of this as is two right triangles. We have one right triangle here, okay, and I'm going to call that distance all the way across that, I'm going to call that y. And then we have a smaller right triangle here, and I'm going to call this short distance z. Because then you can start to see the key strategy for a problem like this. If I can find the distance, if I can find y and then find z, then y minus z will give me what's left over, x here. So this is just more complicated because, one, I'm going to have to solve two right triangles and then find the difference of their sides here. I'll find y first, then I'll find z, we'll subtract them, and that will give me the width of the river there at x. Now the second reason this is complicated, or just to keep in mind, is that they've given us angles of depression, but notice these angles are not part of the triangles formed by the wall here. Here's where we just need to remember our transversal rules. Because that gives you a way of transferring angles across. If we remember, if you have two parallel lines, and if I know this angle up here, that angle is alternate interior to this angle here. So what that means is basically, if I picture these as my two parallel lines, this is the transversal. 58 is congruent to the angle opposite of that. So that tells me this, because that forms a transversal, or I oftentimes think of it as a Z. This forms alternate interior angles. So they'll oftentimes give you these up here. That's the same as this one down here, 58 degrees. Or if I look at this more shallow line here, the 74 angle, that forms a Z here, or alternate interior angles here. So that means this must be, oops, ran out of room there, 74. So that's the other trick, is realizing that these angles of depression can be translated to angles of elevation by remembering your alternate interior angle rule. So just trace those out carefully. This forms the Z right here, so this must be 58, and then the 74 is this angle, so that comes down here, that's 74. So now it's pretty simple. Now I'm just going to be setting up my two equations. Notice I'm not using the hypotenuse here. I'm using from these angles opposite and adjacent. So this is all going to be tangent. This is all going to be tangent. So let's go ahead and start with the big one, 58. So tangent of 58. Again, the angle is always next to the trig ratio. Tangent of 58, and I'm doing tangent again because look, I know the opposite and I don't know the adjacent. So TOA, opposite over adjacent. So 191 over, I'm doing the big one, so y. 191 over y, we've figured that out, that is y equals 191 over tangent of 58. Let's work that out in our handy dandy smartphone calculator. Tangent, oh nope, I'm going to start with the 191. 191 divided by tangent of 58. It's going to be to the nearest tenth, it says in the problem, so I'm going to do 119, so that is y is approximately 119.4 meters. Okay, so that means this whole distance here is 119. So if I can find z and subtract them, I'll know what x is. So let's set that up. Okay, we'll just switch to black. Why not? So now we got this little triangle here. So I'm going to use my 74 angle. Tangent of 74 equals opposite 191 over adjacent z, and it's exactly like, again, once you get comfortable with it, you're going to be so fast at these, you won't even have to, you'll need to show your work, but you won't be able to move much more quickly. So it's the exact same problem. No, now we're doing 191 divided by tangent of 74, 57.8. I'm sorry, whoops, 54.8. Sorry, got to learn to read. So z is approximately 54. Notice we can be happy with that result because y should be considerably bigger than z, and that's what we've got, 119 versus 54.8. So now let's just fill this out, find the difference. 119.4 minus 54.8. 119.4 minus 54.8. Whoops. Did it too many times. Do it again. 119.4 minus 54.8. 64.6 meters, which if you're using the back to get your answers like you should, that is correct. 64.6 meters. So that is the distance of this beautiful, fresh flowing river. All right. So again, a little more complicated, but only because of the steps. The trig is the same as we've been doing. To keep in mind, being able to flip these angles down here, and the idea of which triangles need to subtract from which in order to find the missing distance. Okay, number 15. The watchtower spots a fire off in the distance. This is important in the West, here in places like California where wildfires are a problem. It says that it spots the fire. First of all, it says his tower is 120 feet. If you like heights, there you go. You can go sit in one of those towers. And then he spots it at an angle of depression. So that means it's coming off from horizontal here of 3.5 degrees. This is a lot like the airplane problem we did on the homework. 3.5 degrees. Now because it's an angle of depression, and then they want to know the horizontal distance. So they want to know how far it is. They want to know this distance to the fire. Okay, so my main choice is, do I want to use this triangle here or do I want to use this triangle here? Because it's an angle of depression, I think it's simplest just to do something like this, like we did with the airplane. There's my right angle. There's my distance between the tower and the fire. And I just need to realize, 120 feet, that's this height over here. 120 feet. We'll put that right there. Simple right triangle problem. I can use this one down here, and this would be my x, and this would be my 120. But then you'd need to subtract 3.5 from 90 and use that angle here, 86.5 for your angle, and you'd be fine doing it that way if you'd like the work of a little extra step. Why not? Okay, so let's set up our ratio. Notice again, no hypotenuse, so it's opposite over adjacent, so that's tangent. So I'll just do it right in here. Tangent of 3.5 equals opposite 120 over my distance I'm looking for, x. All right, we've learned, we're getting good at it. 120. That's why you need to practice and do lots of problems, because you'll get good at these things. Tangent of 3.5. So I'm going to divide those, and we shall see what x is approximately. Here we go. 120 divided by tangent of 3.5. Okay, it says round to the nearest foot, so 1,962 feet. 1,962 feet. And that is how far away our heroic fire spotter is from the fire that he has spotted. Save the trees. Okay? So 2 typical problems. This is really basic. This is a little more complicated that you'll run into, but if you can do these 2, you're in great shape. Have fun.